So 200 milliseconds, ladies and gentlemen, is the time which takes for your eyes to wink once. And 200 milliseconds is the time it takes for the browser to load a page. And that is the lifetime of a programmatic ad targeting, ad impression. Okay, what is this programmatic ad impression? So if you go online and you go to any of your favorite websites, okay, and then you go there and you log into the website, and most of the sites, 99% of the sites, serve an ad for you. Okay, how do they know what ad to serve for you? So you go to the publisher's site, and the publisher will ask, okay, if it can serve some ad for you. Some of them publishers, like the Googles of the world, are intelligent enough that they will serve the ad for you directly from your other behaviors which they have seen. But otherwise, it'll ask for an ad server, is there an ad that can be served for this particular user? And then if the ad server says yes, based upon talking to the DMPs, that is the data management platform which is behind the ad server, it may serve an ad. Otherwise, it's asking the next item in the ecosystem, the programmatic SSP, or the server-side platform. Hey, there is a new user who has come here. Okay, but how do they know which user? Either by your cookies or by your user ID, password, login information. Somehow they know, okay, who is this user? So Satya is online, so what ad can we give to him? If the SSP knows, okay, we can serve an ad for this particular person, it'll ask the ad server, okay, go ahead and serve the ad. So the publisher publishes the information and leaves the holes for the ads, and the ad server fills in the holes there. If not, what happens, within the 200 milliseconds, it goes for an open bid. So there is a bidding happening, eBay-type bidding happening online and real time within the 10 millisecond, where everybody is trying to get or buy your slot, okay? And that is where the DMPs and the various platforms come to play. And the bid process goes, over and over a couple of times before the final bid is made, and then whoever wins will let the ad server know, go ahead and place the ad. So where do we, Nielsen Catalina Solutions, fit in? First of all, before we go there, who are we? So you know about Nielsen. Okay, everybody is a love-hate relationship. Okay, if your favorite program got yanked from your TV, blame it on Nielsen, right? Okay, so Nielsen is in about 150 countries. I think we have a presence in almost every country that is represented in the UN. Okay, so we're primarily TV, online, behavior analytics company. Okay, so we do not do qualitative analytics, saying that, okay, this program is good or what, but we do quantitative, meaning, okay, how many people watched the program, how many people looked at the sites, how many people bought the item. So this is basically a TV viewership, individual households at the household level. And Catalina, the other parent company of Nielsen Catalina, you know about them. They are the marketing company which has presence in almost every point of sale terminal, where they look at your actual buying behavior. So they have buying behavior about 70 million plus households in this country. And together, Nielsen Catalina Solutions has the largest single source anonymous household level watch and buy behavior. So at the anonymized level, they don't know Satya. They don't know I live wherever. But we know, okay, there is this individual, Asian American, blah, 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 with this income level, having this behavior, buying behavior as well as the watch behavior. So what do we do with this information? Is basically do three things. One is basically do the targeting. What kind of targets can be placed? What kind of ads can be placed for this particular person? And then measure the target reach, and then measure the ROI. So he was talking about, the gentleman before me was talking about how they measure, how the distribution, etc. So that's what is measured by us too, right? So by the numbers, more than about 50 odd media companies are working with Nielsen, Catalina Solutions, more than 100 agencies, and we specialize in CPG, consumer product groups, okay? So the items which you buy in grocery stores, or items you buy in pharmacies, the OTCs you buy in pharmacies, things like packaged, things like Tide and Whisk and stuff like that, to cereals, ready-to-eat cereals, to cheese, to medicine on the over-the-counter medicine, okay? And we track more than about 300 plus national brands, and we track about more than 1.7 million UPCs, okay? So this is lots and lots of data. So what we do, we match what customer watches online with, or online, or TV, or mobile, with what they actually buy by having the single largest anonymized single source households. So more than 41 million, more than 100 million homes, we have information about their watch, and more than 70 million homes, the same home by behavior, okay? So what are the other types of information which get used in doing this decision? We keep track of the demographics. So how do we get the demographic information from? So most of the time, every individual here has interacted with a rating agency through some ways, right? So everybody has a credit score. Everybody has communicated with one of these agencies either directly or indirectly. So through that, we may be able to get the demographic information of the households, right? And the shopping behavior, as I was telling my parent company, Catalina, they have the shopping behavior of individual households. Okay, they track anonymously, again, okay, not at the individual level, not Satya or not Mrs. Satya or not Master Satya. So it is basically the household of Satya, right? So at that level, we have information about the shopping behavior and other things like the lifestyle or the life choices. Okay, like single parent families, or single income source, or like older families, or families with highly disposable income. Then again, the behavior, other behaviors such as custom surveys, etc., etc. And finally, the actual brand UPC level shopping data of about, I was telling you, about 121,000 brands we do on 1.5 million UPCs. So in summary, have the largest single source shopping and watch behavior data with over about 9 quarters of historical data to always look back from, because we have lots and lots of data, because several trillions of orders and trips come to us every day. So it's not worth keeping for a longer time, because if I bought something 3 years back, it's not useful for me to predict my behavior now. So about 9 quarters of this, and have access to about 90% of all the online homes, okay? And with over 10 years of experience in running several studies. So what do we really do? We do 3 things, okay? We call our platform as Advantics. First is basically audience selection. Who to select for this targeting? Remember, I was talking to you about the DMPs, who places the ad, who says, okay, what ad to be placed to who. So based upon all this behavior, I was talking to you about demographics and buying behavior, able to predict the behavior of individual households, and then place them into various buying buckets, if you may, okay, various targets, and then rank them. So for example, if a home has a new baby, so the likelihood of that home buying, say, diapers or buying baby food, baby formula food, is very much higher than a home where there is no children and people are 60 plus in that home, okay? But other way around, the adult inconsistent products will be more popular there. The adult diaper will be popular there, whereas the baby diaper is popular here, right? And then what we do, we actually do the activation. So these homes are all ranked, as I was telling you. So there's a home so let's assume that we have 3 or 4 targets, the campaigns which partners want to run. So they want to run a cereal ad. They want to run a baby food ad, a pet food ad, and a medicine or a OTC ad. So now a home is ranked across. So a home may get a highest rank in baby food for a home which has a newborn baby, and maybe it doesn't get a high ranking for the pet food. So the DMPs have this ranked home, the lists for the homes. So when Satya goes online and the information about Satya is passed to the DMP. The DMP checks, okay, where is Satya's home fits in? Okay, it fits in which slot, which is the best reach for him, where I can convert him to buy stuff. So finding, okay, it's better for him to give him a pet food ad versus giving him a children food ad. So that is what is the audience activation. Finally, measuring. Measuring is measuring two places. One is in flight. So typically campaigns run for, say, 6 weeks, 10 weeks. So there will be ads placed. Now I want to see after second week whether the ad is really productive and resulting in buyers, people converting to buyers. That is in flight. So as the previous speaker was talking about, you have distribution of ads across various media. So I want to say, okay, I want to spend so much money in TV versus so much money in online versus news media, paper, or radio. Okay, these are some of the things which we track and we distribute. So now the ad agency can determine, okay, now the reach and the result conversion through digital is much more than, say, in phone, mobile, or it is much better than TV. So let me do a reshuffling of the dollars. So that's what we can do during in-flight. And then finally, post-campaign, once the campaign is over, whether the result was a good campaign and did it result in a good ROI. So summing up there, precision marketing, in-flight optimization, and sales lift measurement. So the important thing here is we measure CPG sales primarily today, okay? So I was talking to you about the ecosystem, the first slide where we talked about the 200 millisecond story. That is where NC Solutions fits in. So it sits behind the DMPs, the DSPs, the publishers to provide this ranked list of homes. Okay, that is the targeting. Okay, and some of our partners and publishers and DSPs and ecosystems which are using the data for CPG are these, okay, ranging from Google's to Yahoo's to Apple to Microsoft to CBS's and Catalina to Meredith's, that is basically Time magazines, okay? So just quickly going through the sales lift measurements. So the questions which are answered are basically, did my campaign work? Did it impact the loyalty? Did it increase my sales? Did it convert people? Then about the various brands itself, okay, how did my sub-brands work? For example, sometimes what happens is if I am running a campaign for, say, cereal, okay, if there is a shortage of milk, so there is not enough milk and milk prices go up, even though I run a campaign for cereal, my cereal sales will drop because people who buy ready-to-eat cereal are likely to buy milk, and then milk prices are high. So you have this halo effect, right? So because of one thing, which is not even related to cereal, is impacting the cereal sales. So how do I do that? And many times you have seen people like Kellogg's or whoever, when they want to run a campaign for cereal, they will say, okay, you buy 2 packets of cereal, you get a milk free. So how do they know? How do they relate? So those are some of the things which we do, and which we compare the total category versus the local. For example, I think a few years back, there was an ad played by Coke. Okay, so Coke had the ad, I think during Christmas or sometime, when they had this bear coming there, and the polar bear showing that. And suddenly we saw not only Coke's sales go up, but also Pepsi's sale go up without Pepsi making even spending any ad dollars. So how did it happen? So many of the people who are buying Coke, but who are animal lovers, somehow move to here. So you see how these things affect and these things change. Okay, so my competition may affect me. My categories, my other categories may affect me. Okay, so how do we actually do the sales impact? Okay, typically it is basically what is the penetration of my ad? So how many homes did I hit versus multiplied by what was their actual change in behavior? How much did they buy and how often they bought? So this gives me the total sales. So having said that, how do I calculate my ROI? So if I have exposed to, say, about 9 million homes, for example, in my universe. So let me put some examples here. Okay, this is all hypothetical, okay? Say Yahoo. So Yahoo has about 70 million homes, and the Kellogg's went to Yahoo and said, okay, let's place the ad for cereal on Yahoo sites. And if Yahoo reached 9 million homes in this example, and we find that since we have the single source data, we can track what ads were placed for whom and how did they buy. And if they resulted that, okay, these homes bought, and they were buying $2 worth of stuff, and now they bought $2.52 in this example, 2.52. So the incremental change is 0.52. So this and an average. So for this 9 million homes, the 52 cents equate to about $4.8 million, right? And if Kellogg's had spent, say, $1 million on this ad whole campaign, so right there we know for every dollar spent, we had a $4 incremental sales. So this is one simple example, one simple data point which we report, okay? Now, so much about Nielsen, Catalina solutions. So where is H2O coming in the equation, and where does it play? And I want to talk about how we have implemented H2O as a service, okay? We have been hearing about all the data science stuff, but this is more like engineering, okay? How did we implement? And ours is a different type of entity, okay? Number one, Nielsen Catalina Solutions is the very existence of Nielsen Catalina Solutions is because of big data and data mining and data analytics. So we don't do it as a byproduct, unlike many other companies. And then our customers are not our employees. Our customers are outside, and their analytics teams will be using our systems. So it's like I am building a service which is going to be used by the masses. Okay, how can then H2O play in that game? Okay, so the methodologies which we are using in NCS is superlearner, obviously. And we did analyze and study the various techniques, right from regression to GLMs to trees and to binary trees to GBMs, etc. And we found that the GBM gave us the best quality and fast data. So what did we do? We found a combination of GBM with a little bit of elastic net regression provided the best combination for us, right? So what does it mean? So if we have various attributes, if something we determine as important, so we gave them greater weight versus which is not important, lesser weight. So we have these variables. So how do we determine the variables? Say, for example, if Tide wants to run a campaign and they want to measure the campaign, so we found that, okay, homes with little children, so the presence of children is an important attribute which we had to boost it up for Tide, because people who buy Tide are people who have a lot of children at home are likely to buy more soap, more detergent. Again, other buying behavior, people who buy ketchup and having little children, so likelihood of spilling ketchup is higher, and the requirements of the need for Tide is higher. So you see that for a particular study, we increase or decrease the weights given to various attributes, okay? So we run the superlearner, and it runs and creates a number of models, okay? So we do not discount any models, but what we do is even the poor ones can contribute. So we give enough weights, like as I was talking to you a little bit before, where we assign weights to the various attributes. We weigh the models also, and then instead of using the ensemble which is provided out of the box, we created our own, right? So we find, okay, what is a good mix, and we are using that. Also, we tease out estimated answers based on biased versus unbiased. So if I'll give you an example that will explain how this TMLE is used. The principle which we have applied or we are using, we call it the WAVE principle. So we have a set of independent variables, And the independent variables are basically, say, the demographics, for example. And then the sales is the final outcome. So I want to take from the home's attributes and predict the sales. But I have the sales with me. I have the demographics with me. I have the sales with me. So I want to find out what influence the ads had. So did the user buy just because the item was on sale, or he bought it because he wanted it, or he bought it because he saw the ad? If there is a gentleman who's buying soda, and let's say he consumes 4 cans a day, 4 to 5 is not a big deal. But if a gentleman who's buying 1 can of soda and suddenly he started buying 4 cans of soda, then there is a real reason why he got changed. Okay, is that change due to the watching of the ad, or some other reason? So that is what we are trying to predict. So the wave principle explains, okay, so build models, okay, from the independent variables to the sales, and then look at the homes, whether the homes were exposed or not. So if a home was exposed and the home bought the product, then we'll be able to predict, okay, what is the lift due to the exposure? When they say exposure, it is basically exposed to an ad. So the lift predictions, typically we do 2 types of lift predictions. One is the relative risk, RR, or the average treatment effect. Okay, based upon that, we find the average lift of all the rows. So if there is a model, if in the previous example, the sales was a result of the actual exposure versus whether it was a straight sales. Okay, so these are the 2 ways of looking at the model which we predict, and quickly about how we have implemented. So what we have done is we have taken the H2O servers, H2O, and we treat it as a black box. We build a proxy around the H2O, and we prepare the data which has to be fed to the H2O. So all these things are behind the ESB, Enterprise Service Bus. So the client process is nothing but a browser. So the user goes to the browser, he makes all the selections, blah, blah, blah. He wants to run a study, click the button, and then the ESB spawns data prep processes which look at our mega warehouse, gets the data processed, and extracts the data in a flat file in NFS, and then sends that to the H2O cluster through the proxy. So what happens behind that? Okay, so what we have is each cluster is about 6 servers, made up of about 6 servers, about 56 CPU threads. We have several clusters. Based upon the load, the clusters go up and down, we'll see. So what we do is basically we have split the process into multiple little steps. So first we load the file, parse the file, then run the analytics. So that is where the H2O comes to play. So you see that what we are doing is we are using H2O as a service. Okay, it's an extension of the whole platform. Okay, we are not using H2O like through the UI, through the browser, etc. But we are using it as a service. So the whole process can run for several minutes to several hours. So the user might have just gone, may have scheduled a job and gone. So it is most likely a batch process. So the system checks the H2O through the proxy, which we were showing, to get the results, and then finally store the results in a data warehouse, data model, or data mart, or small data set, maybe in Oracle, and then finally go through the Excel generation. What the user wants, our user wants eventually is, give me a sheet of what are the various data, how did it change, etc., and also maybe give a graph like which we are seeing all this while. Okay, so you see that we have 2 sets of things. One is basically to manage the cluster. The other one is actually do the job. Okay, so to manage the cluster, we have implemented a governor through the general ESB. So by the way, I am an open source believer completely, and I was with JBoss before. So obviously, I'm using JBoss Enterprise Service Bus there as the ESB. And the workflow is custom built using JBoss workflow, obviously. All right. And what happens is we have this ESB supervisor invoker, which looks at the available clusters, H2O clusters, which need to be brought up. And at every request, it will bring up the cluster and give it to the governor. The governor, when it gets the request, it does all these other things through the H2O proxy, which we have custom built, right? Through go import the files which were created by the data prep processes, parse the setup, parse the data, then do the cognitive analytics, modeling, extracting, storing, et cetera, et cetera, et cetera. So you see that our implementation of H2O is slightly different. It is not user by user basis, but it is more like a service. So what are the lessons learned? Okay, we did try, as I was telling you, different superlearner types from linear regression through trees, through GBMs, random forests, etc. But we found that GBMs were the most accurate, but most expensive. GLM is fast, but we're not accurate enough. But hopefully, this morning I had the opportunity to talk to the other lady, and I think the new implementation, maybe it'll make it better. We'll see, okay? And that's what I am hoping. And we use it as a service, and we call it via Java. All our applications are enterprise Java-based. So we use the REST APIs to call H2O. And we have now migrated to H2O 3. 3 is much better now for long term, etc., compared to V2. Version 2 we had, but we went through a good pain, growing pain before we migrated to 3. And finally, we got the best support from H2O, obviously. We had a dedicated coordinator. I think we are one of the very first customers to sign up for H2O support. So we got, and we had a very proactive and effective lightning fast support team. And one of the things which I want to, which stands out, I think yesterday, Matt would have talked about it during the Sri's talk last morning. Right. So our goal was basically to do all this data processing via a data manger inside the cluster itself. Okay. We wanted to join, slide, group, etc., and then do the pivoting, etc., inside the platform itself. And our goal was to use Java as an API. And we were talking about millions and millions of data. Okay. So we had our super developer, Matt, who jumped on it, and he has built a version for us now, and I think it is now in beta, or you're ready to give it to us, so hopefully it'll be there. So I was told that yesterday you had a party, and you had Star Wars characters coming. Okay, I was wondering, why didn't you have Superman and Superwoman characters? I think that's because all of you are Supermen and Superwomen. Yeah. Only difference is Matt, the Superman who was helping me, between Matt and real Superman is Matt wears his underpants inside, not outside. Right? Sorry, bad joke. Okay. All right. Anyway, so thank you, Matt, for helping us do that. And any questions on the implementation? Yes, sir.
All right. Wait for the mic.
So for a single source, what's the glue that connects your data together?
Okay, good. So we have a third party who's helping us. So we don't want to have any personally identifiable information, PIIs, in our data warehouse. We don't want to know it is Satya or it is 123 Main Street. We don't want to do any of this. So we use the third parties. The third parties are like the Experience, Axioms, and the Trans Unions of the world, who are the agencies who do the ratings, right? Or credit agencies. Okay, so they have information about everybody. So they generate an anonymized ID for every home, and they give us. So the partners send their IDs to them, and they communicate only between them. They don't give me anything. So the third party anonymizes the homes and gives me, and they give me the individual IDs and the demographics about the IDs plus the linkages. Meaning, okay, let's assume you have a Yahoo ID, you have a Safeway card, you have a Mac ID, and you have, say, Xbox, okay? So you have 4 different IDs at the 4 different systems, right? So those partners communicate with Experian or Axiom, and I get 1, 2, 3, and ABC, D, E, F, G, H, I. So the linkage I get and the demographics. I won't get the personal identifier information.
So one more question. So on in demographics data, I mean, the dimensionality must be a big thing,
Sure.
and also the sparsity,
Sure.
especially self-reported demographics,
Yeah.
where the data is very sparse. So
Yeah.
do you do any upfront reduction, or
Yes.
how do you do the imputation?
Yes, yes, yes. Okay, so the demographics data we not only get from, say, experience of the world, but Nielsen also has it, okay, and our partners also have it. So we do a lot of ETL before we finally come up with it. So we have a sort of both modeling technique there, as well as we were saying this morning, that, okay, we model, okay, based upon the number of people in the home, the likelihood of blah, 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 for example, say, gender, okay, so for example, so we want to say, okay, if the name sounds like a female name, and so it's more likely it's a female, right? And as well as we munch the data, clean up the data. Okay, so we get the data from various sources. So if one source says one person is a male, other source says a female, and we know for sure that second source is reliable. For example, Nielsen data, Nielsen touches the people. They go and talk to the people. So if Nielsen tells us, no, it is a female, then we put it as a female, even though Experian thought it was a male. So we have this cleanup. Yeah. Obviously, 85% to 90% of the time we are right. There is 10% which is the exceptions always. Yeah. But we are talking about 140 million people, households, and 350 million people. So the amount is taken up.
Do you reduce the dimensionality?
Yes. No, we don't reduce them. We keep track of every single attribute. It could be 400 demos which we are managing today. 400-person demos, household demos, and about 10 to 15-person demos, about 16 people in the home. So it's very wide. Yeah. So what we do, that's the reason why we have this data prep process, where we extract the data and then flatten it out so that the engine can run it quickly.
We got two more.
Are you working with any direct response advertisers? And if not, how would this sort of system would be different for direct response versus offline attribution?
Sure. So we cater to both contextual as well as addressable, okay, and also direct response. All three are there. So see, for example, contextual. For example, TV. Okay, TV. Although there is the features are ready, but we do not have addressable TV, right? So we cannot, the TV is generally not where the ad goes to one home versus the other home, doesn't. So we do both. So in that is a different model. So there we look at just the demographics, and we don't care about when we do the targeting, remember? So instead of giving the end user or end customer the list of actual IDs, we give them just, say, a demographic base, or it could be like a region base. So we say, okay, this could be, okay, if you're going to do the ad, the best reach for you would be in these zip codes. For example, Mexican food, the best is South California or South Arizona or whatever. Don't place Mexican food, ready-to-eat food in North Dakota, which is useless, right? So we do that. So, and also we do, as I was telling you, print. Okay, print is also one of them. Radio is another. So print is contextual, not actual. So, but there's a combination there. If Times, for example, sends you directly the magazine as a subscriber, then they will place that ad accordingly. You have when you get a book. If you subscribe to a book, sometimes you get a special ad for you specifically, right? So that's what they do. Yes. So it's a combination.
Hello. Yeah, I saw you mention about campaign analysis, and also you mentioned about conversion.
Yes.
So in case where the ad is projected onto a TV,
yes.
I'm curious to find out how are you trying to track the conversion?
Yes. Yeah. One thing which I did not talk about is how we get the exposure data. Okay, so the exposure data we get either from the panel-based Nielsen panels, or from our partner set-top boxes. So the set-top box knows that it has placed the ad for you, right? So these are all spot-based. On the TV side, it's all spot-based, right? So if you have watched a program and there was a spot in that program, Okay, your set-top box was on from, say, 6 to 7 p.m., and there are spots there. And if there was an ad for, say, Tide in a 6:15 spot, so we assume that, okay, you have watched the ad. Okay, obviously, we cannot know whether you were physically present there or the TV was just on. Okay, but that we can do through the Nielsen panel. So the Nielsen panel homes, they have various ways to capture who actually watched. So if our partner asks, okay, give me exact people who watched, then we restrict to the Nielsen panel and then do the modeling and extrapolation. No, that's what we have, our single source, where we convert that and we say with the household. Yes.
I'm going to repeat the question so that everybody can hear it.
Okay.
Could you? So the question was, does the panel
know the conversion? Does the panel know the conversion? So the conversion is through our single source. So we know we have the watch behavior, we have the buy behavior of the same home, so we know, okay, it was converted.
All right, so can we thank our speaker?
Thank you.